Hello everyone. Today we will see primer designing using different tools. In our practical course, as you can see, there is a procedure which is given as the 14th item. You can open that to see the procedure. So, in the procedure, the first step is copy a nucleotide FASTA sequence from NCBI. So, that is the first step. So, the next step is you have to design the primer using either primer 3 or primer blast. So, we have two options, online options. You can use both of them or either of them. So, the first step, as I mentioned, it is the retrieval of a FASTA sequence, nucleotide sequence from NCBI. So, you can just search GenBank in Google. So, in NCBI GenBank homepage, you can select the nucleotide from the database, then search for any sequence of interest, for example, cellulase. So, it will list all the possible sequences from different sources. So, here I have filtered genomic DNA or RNA, and also I am applying another filter from say Escherichia coli. So, the result will be limited to cellulase genes from Escherichia coli only. Now, there are complete genome sequences or circular E. coli sequences are there, which will be very large. So, it will not be easy for you to access and copy the required region. Whereas, there are other regions like complete cDNA sequence, which is available. But one issue is that if you are selecting a complete cDNA sequence or partial cDNA sequence, it will not be sufficient for designing a primer for copying the entire gene, because it is only a part of the gene sequence that you are copying. So, for getting a complete gene, you need the flanking regions on both sides of the sequence. So, in that case, you require a complete genome sequence, so that both sides or flanking sequences of the complete gene is available only in the complete genome, not in the partial sequence. Because say you are copying, your target is to copy a gene of 1000 base pair length. So, to completely copy that sequence, you need a primer which will lie behind the 1000 sequence and end after the 1000 sequence. So, the entire region of the DNA sequence or FASTA sequence that you require, that you need to copy, should be longer than the sequence that you want to amplify. Okay. So, which will be generally available in the chromosome only, not on the or the complete genome only, not on the partial sequences which is shown here. So, anyway, just I am mentioning what is the difference between the complete sequence and the partial sequence. For the time being, I am copying the complete sequence only. Just we need to detect the presence of the gene by designing a primer. But for copying an entire gene or amplifying an entire gene, you require a longer region from a complete genome. Now, I am opening that sequence. So, this is the FASTA entry, the GenBank entry. You can click on this FASTA. which will give you the FASTA sequence. So, now starting from this region. So, from this point onwards, this is the single letter code of the bases that is present in the concerned CDS. So, this is the region that you want to copy and design a primer against the sequence. Okay. Now, the next step is you can access this website Primer3 just by clicking on and right on that. It will be opened in a new tab. So, you will have an input box for copying and pasting of the sequence. The sequence that you just copied from these site, this can be copied and then you can paste it here. So, the sequence is there. Now, you can come down. You have to pick the left primer and the right primer, and also there are some other options like additional options which is given, like you can give a name, for example, cellulase, a sequence ID or something, and you can give many other arguments to cover the region of the primer that you want to amplify if it is required. But anyway, right now we are not going to that portion. And general primer conditions were mentioned here, like the primer size, it should be of minimum 18 and maximum 23 bases length. Optimum or preferred primer length is 20. The primer TM or the TM value of melting temperature of the primer should be 57 to 62. Optimum is set at 59. Now, this is a primer GC content should be between 30 to 70 and optimum is set at 50. So, accordingly you can modify based on the sequence similarity and all the specificity of the primer that is required. You can change these parameters of the GC content and TM value. So, there are a lot of other options. Generally, you do not have to bother about all these things if you are not designing a specific primers at advanced level. So, right now I am clicking on pick primers. So, now you have the result. The left primer will start at 491 base, it is having a length of 20, and the right primer will start at 686 as the base, and it is also having a 20 base pair length, and this is the TM value which is almost close to the value preferred value that you set. GC content is exactly 50. So, all the conditions were met and the primer is actually, this is a left primer, this is the suggested right primer. So, this is the entire sequence which is given as an input. So, this is the first primer, forward primer, which is designed against this region. And this is the right primer. And you have to keep it in mind that using this primer set, you can identify the presence of the gene only, because it is amplifying only the region between what 491 base to 686 base. So, the region which is flanking on both sides were not amplified. So, this type of primer is not suitable for a complete gene amplification. As I mentioned earlier, if you are looking for a complete gene amplification so as to clone and express it in some target, then you require a much longer original DNA sequence which will include the gene of interest, and there should be additional regions on both sides of the gene of interest, so that you can target that region for designing the primer, and as a result the product will cover the complete gene product. So, this is it. So there are alternative options are also there, starting from different start points and end points. 4 other sets of primers were also suggested, and all other their length, TM value, and GC content, etc. were also mentioned. So there is not only a single option for primer in this region. There will be multiple start and end points, or forward and reverse combinations will be there with a different length, and these are additional primer options that is suggested by the primer 3. So these are the primer designing results using the primer 3. Okay. Now we come to the next one, that is the NCBI primer blast. So you can use the other tool like NCBI primer blast, which will also give you a box, input box for pasting the FASTA sequence. Now these options were actually for setting the range of the forward and reverse primers starting from first say 50th base to 100th base, or the primer will be set between that range. So the forward and reverse primer start and end points can be set by giving value on this column. So from which region to which region you want to design the primer, that start and end points can be mentioned here. So there is another one like so. Okay, here is the minimum and maximum product length. The product size should be 72,000 base pairs length, and this is the melting temperature 57, optimum is 60, and maximum melting temperature set is 63. So that's about TM. So various other options were also there. You can just click on the get primer results. Advanced parameters were also available at the bottom. If you are interested, you can give additional parameters, additional arguments in that region also. It may take a few seconds. Okay, now the results are there. So there is a graphical representation of the results starting from different points. So this is a forward primer, this is a reverse primer, and from different starting points and different ending points, different primer combinations are there. Forward and reverse primer combinations were shown in the graphical window, and at the bottom detailed primer report we have many primer pairs which is given. This is a primer pair 1, and both the sequences were given, plus and minus to answer, and the length is 20. Start and end points were marked, then TM value and GC content is there, and also the self complementarity, which is also another factor while considering the primer design, that is also mentioned there, because the primer should not be self complementary, and if it is a self complementary primer, the primer will pair between itself, so that it will not bind to the template strand and amplify. And self complementarity value is a significant parameter while designing the primer. So GC content, TM value, and self complementarity, etc. were optimal, and such primer pairs were actually marked here. You can use any of the combinations, and if your intention is just to detect the presence of the gene, any combination of the primer can be used. So this is important when say we are designing a multiplex PCR, where the multiple primer pairs will be amplified in the same mixture, and the products will be distinguished based on the difference in the amplicon length. So in that case, you can choose the optimal size product so that you will get a distinct band representing every gene. So anyway, that's of relevance in case of a multiple PCR system, and you can use any of the combination of the forward and reverse primers for specifically amplifying and detecting or identifying the gene. And this is about the primer blast software that is used for designing of the primers. Okay, thank you.